Okay, P.S. Please, on the BC review number 1, look at the back page, everyone. Look at the bottom of the back page. Don't you dare fit your FRQs in that little space. Get a blank piece of paper, work out your FRQs, A, B, C, D, with the year, and staple it. Don't you dare fit your FRQ in there. Not funny. Not cool. I wouldn't grade it. There are 2 FRQs. Don't you dare fit your work in there. No, that was not a challenge. You rebellious generation. All right, so I won't go brood of vipers. Here we go. Shh. Coming back. It's not true. That's why I'm not. Okay, what questions do we have? Numbers 1 through 6.
Everything D.
Everything D. Yeah, I heard that from someone else yesterday. John, give me a starting place.
3, 5B.
Oh, it's a B. Okay, any A through C's, then we'll go do the D's.
D.
All of the D's are
John, yours was 5, right?
Yeah.
Okay, let's just go to number 5 for a while.
6D.
Oh, 4B.
B. B and C. Let's go to number 5 because we have multiple parts on this one. That way we can do them all together. Just to be honest, you guys know your banana potato problems last year. Insta and Twitter, whatever, just blew up. This year, it was the funnel. Literally, the funnel was the problem that blew up. So, with the funnel problem, this would have been, right? Yeah. Georgie's AB year. George and Amanda Johnson and all them. Funnel was not as hard as you thought. We are on letter B. Find the volume of the funnel. Find the volume of the funnel. There are 2 ways to think about this, isn't there? One way is to think about it as a solid of revolution, because you could think about this curve over here being revolving around this axis right here. You could think of it as a solid of revolution, but what in the question itself points to something different? Corey?
Oh, I'm sorry.
A question on A? Do you want me to go back there?
Well, yeah, I had a question.
Okay. A in general, don't get stuck up by the variables. Average value of anything, you do 1 over B minus A.
If you integrated R and then plugged in what R is, would that be okay?
Hold on.
1/2 R squared and I plugged in for R.
No.
You can't do that?
No. Because remember, you have no idea who R's function is, and so to apply the power rule to something that might not, does that make sense? It would be a travesty. Ooh, good word. Anyway, coming back. Letter B. So some of you might have thought solids of revolution, but that was absolutely not what you were supposed to do because it says has circular cross sections. Whew, I was holding my breath on that one. So circular cross sections. I almost died. Circular cross sections. Does that mean we're still going to use pi r squared? Yeah. Who's r? This guy. Who's r? That guy. Pi r squared. Dun, 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 dun. From the bottom to the top, which is the 0 to the 10. There was nothing else to consider besides circular cross sections. Use geometry formula pi r squared. And who is r? You got him. Plug him in. Dun, 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 dun. Noah, go ahead. In the bathroom. Oh, all the napkins ran out. Yeah, go ahead, bud. Sorry. Jason. Oh, sorry. I was just solving. Find the volume of the funnel. Hold on. Yes, because they gave you 10 inches, so you need the inches cubed. Guys, on this one, if you're grading your FRQ, some of you didn't realize the answer key was online. The answer needs to have the number and the units. Sometimes they separate those. Like sometimes there would be 1 point at the very beginning for all the proper units. But for some reason, it seems like in the more recent ones, they've actually made the answer include the units. And if you don't have it, you lose the answer. So don't let that happen. Wait. Oh, and we haven't gone to C. Oh. No. Cross sections, remember, the volume is equal to the integral of the area. And the differential adds that extra piece as far as the depth. Does that make sense? Good. Good. But the question is, do you see what you should have thought, right? When you see, you think. Just be careful. Letter C, then this was, Katrina, you had this question, right? C? Oh. Did anybody else have a question on C?
Oh, wait, hold on. I got you.
Okay.
So, were we supposed to solve, like, what would be an appropriate time to box in for both A and
Right here.
C? Oh, you box in there?
As soon as you have your numbers plugged in, stop.
Plug in your numbers.
Plug in your numbers. Like, don't stop here because this isn't finished yet. They haven't seen your f of b minus f of a. But as soon as you have it, now, pause. Since you haven't simplified, don't forget to put the units. Put the units after. But as long as you have all the numbers plugged in, you're done. Stop, stop, stop. Yeah, go ahead.
So if you did chain rule, but you didn't.
P.S. Related rates.
Yeah, but you didn't do your entire derivative correctly. Do you still get the 2 points for chain rule? Or is it just
No, chain rule would be correctly applying. So you could get one of the points if you were doing chain rule. But if you made a mistake, that mistake would negate the second point. Does that make sense?
Yeah, because like I did derive the 3, so I didn't have it plus 0, but I did do the 2HDH.
Okay, so yeah, I would say like, I would put it this way. I would do the 2 points for the chain rule, and then that mistake would cancel one out. That's how I would think about it as far as how they would have graded it. Okay, you guys good on this one? Tell me a place you want me to go. Tell me an FRQ. 2? Okay, let's go to 2. Let me know what questions we have on 2. So Eileen said B. On B and D. Okay, so B and D. Pause. What do we have? This is a graph of y. Y being the vertical component, right? The vertical position of a particle. We have parametric equations, and we also know x prime, or dx dt. Okay, cool. So when letter B says find the slope of the line tangent to the path of the particle at t equals 3, you guys translate for me who is slope of the tangent line. What it's always been. But careful, if you say the derivative, people's minds in parametric could go all over. It's what it's always been, dy dx. So dy dx, I need y prime over x prime. And so for y prime over x prime, well, x prime was a simple plug and chug. So that one we could go ahead and, yes, you have your calculator. Yes, you could have plugged it in and gotten a decimal. But yes, you could have also plugged in 3 and just written it there. Totally fine. Numerator, though, stink. Okay, hold on. It's at 3. This is a graph. Here's y. Here's t. T3. Slope. It's linear. I need the slope of y prime at 3, linear. You can use the point 2, -1, and 4, 0. Don't go guessing from here. But 2, -1, and 4, 0. The slope is up 1 over 2, yeah? So then you can go ahead and plug in 1/2. So I do 1/2 over, and I would have just plugged in 3 to be honest, and boxed it. Done. John.
I have a question.
Yeah. Yeah.
For part D, when it says expression for distance, you lose a point if you didn't write that.
But did you write any of that?
I got the other 2 points, but I didn't.
Oh, but you wrote the integrals.
Yeah.
If you wrote the integrals, then you have an expression for distance. Because you're showing the square root of x prime squared plus y prime squared. Does that make sense? So yeah, that'd be okay.
So if I did like the integral and then I plugged in dx dt and I squared it and then I just left y prime squared?
You would have the expression for distance.
Yeah. Okay.
But the integrals, since you didn't finish plugging in, then you wouldn't have gotten the full integrals. Corey,
In part C for the expression,
scroll up.
plugged in 3 under the square root.
For which one? For C?
Yeah, and C, but then in part D they kept T, so would it matter? As long as you show later that you plugged in 3 for your expression.
Well, the problem is for C, you're finding it at 3. You're saying 3, right?
Yeah.
But John was just asking, like, he wrote this part. Like, he actually wrote what he was solving. And so he's going to get the points not only for the integral, but also the expression for distance. You couldn't depend on C because C was speed. There was no integral, so yeah, that wouldn't work. Katrina, you want me to go up to the graph?
Can you explain D?
Yeah. Well, remember total distance traveled, first of all, the forever card, right? Square root of x prime squared plus y prime squared. Now, x prime squared is easy. That's constant the whole time. But as you go from 0 to 2, do you realize how your y prime, your slope of your tangents, change?
Yeah.
So you have to think about y prime being a piecewise function. And technically, guys, we could actually write y prime. You can always, whenever it's geometric, you can make equations. For instance, I could make equations of y if it helps. And I could say, well, y is equal to from, let's see, from 0 to 1. I don't even know where the hole in the whatever, it doesn't really matter. And then from 1 to 2, and then from 2 to 4. And I could actually make lines. Like, for instance, this would be y equals -1. For this one, I could go ahead and do the linear function down to over 1, so that'd be negative 2x plus 1, or t, I suppose. I apologize. And then this one would be up 1 over 2, so that'd be 2t plus negative 2.
How are you doing that?
I'm making mx plus b's. So my intercept is 1. My slope is rise over run, down 2 over 1. So m, negative 2, x plus b intercept. And this one I had to go backwards, so I followed the slope, found the intercept of negative 2. My slope was up, up 1 over 2. Sorry, it's 1/2. Lo siento. Not that you have to make these equations, but check it. If you make the equations, couldn't you just easily be like, slope, derivative of negative 1, struggle, 0. And so I would never get a perfect score in the AP. And then 1/2, I would go too fast. You have 2 different slopes in the interval 0 to 2. So we'd have to plug in, does that make sense? We'd have to split up the integral and say, okay, well, y prime is negative 2 for this portion. I can plug that in, but only from 0 to 1. And then from 1 to 2, now my y prime is something different.
Okay, so you could have just done that by looking at the slope.
Oh, yeah, totally. I was just saying you can make a piecewise function of the slopes using the linear. If you needed to, you can always make a piecewise function of the original function. If you don't like area formulas in geometry, if you're actually finding areas, you could just anti-derive and you could solve that way. Like, there are options whenever it's geometric. You can make those equations. Yeah, but you could have just looked at the rise over the run, yeah? Negative 2, 0, 1/2. Did that answer the D question for the others of you that had the D question? You're using the formula for total distance traveled, but y prime is different based on the different boundings between 0 and 2. Gabby. Okay, so that's number 1. Any other questions besides C on number 1? Those of you that graded number 1, hopefully. Not too many questions you've already had to work through. Okay, this is an in-out, right, guys? They gave you rate in, something's pouring in, rate out, something's being subtracted out. This is different than the banana problem from last year. This is an AB question. This is different than the banana problem from last year because remember the banana problem, the store opened, people started buying the bananas, and the worker didn't go to start restocking until later. So the bounds are different for the banana problem last year. That's why that was a little bit trickier. This one, the bounds, the water's being pumped in at the same times as the water's being pumped out, and you know the initial amount of the water in the tank is 50,000. So for letter C, go ahead, Corey.
For A, even if you get the answer wrong, you put the units right, you still get
Yeah, you still get a point. No, that's why. That's why. Always put those units. You never know. Always put those units. But we're down to letter C. Use your answer from part B. So let me try to get the answer so we can actually see it. Here it is. The answer is 8,050 liters. It's an overestimate because you did a left Riemann sum. Overestimate. Riemann sums, you have to think about the increasing, decreasing nature. If the function is decreasing, won't the left be higher than the right, so therefore over? So we know 8,050. Letter C says use your answer from part B to find an estimate of the total water in the tank. Total water in the tank. Net change. Net change. I want to know the total amount. Now, careful. I'm not just integrating how much water has poured in. I'm not just integrating how much water has poured out or thinking about how much water is poured out. I'm thinking of how much water is in. So whenever you have coming in and going out, what do you have to do in order to consider the amount in the tank? Subtract, which you guys hopefully had to do other places in the FRQ. So then you have to say, hey, to get to the final, which I would have named something else like, well, not W, because that's really W, not R. G, is there gallons? No, it's liters. L, I would probably call it L of T for liters. So L of T, L of 8, sorry, I apologize, not 6. L of 0, the amount of water at 0, which was 50,000 according to the initial. Final is equal to initial plus the integral of W of T minus R of T from 0 to 8. The problem is w of t, I can plug that in my calculator. No stress, it's just a function. But r of t, well, how am I supposed to integrate r of t? What did you do in letter B? Approximate the integral of r of t. So when you take your approximate of the integral of r of t, the left Riemann sum, you can plug that into r of t. Careful, you're not integrating that. That is the approximate of that integral. And then solve, solve, solve. Cameron, I'm good. Thank you. Yeah, Gabby. Go ahead. Let me go down to the grading key so you guys can see it all.
I just wrote IGT, but I didn't actually write anything else. So would the explanation?
Not in this one, just because sometimes it does say just mentions IVT, but this one says answer with explanation. So IVT would be your explanation, because the answer would be that there is one time, would be yes. And the explanation would need to use IVT. So it was a good idea. I would say this it was a good idea. Just try to see how you could have expounded on that, or expanded on that, I should say. Corey. Okay. Number 1, is anybody still grading? No, let me give 3D and 4D were the 2 questions that Corey had. Okay. Hey guys, you know they like accumulator functions, yeah? They love accumulator functions in the last 5 years. Accumulator functions. Okay. This is asking for finding all the intervals for which g, not f, g, who is the accumulator function from 2 to x of f of t dt, where g is less than or equal to 0. My first question would be, do I have an initial point for g? Couldn't I find an initial point for g by plugging in something like, 2? Why would I start at 2 for my initial condition of g?
Oh, because it's 0. That's good.
I'm going to start at 2 and consider my movement from 2 because it's easy. So starting at 2, okay, hold on. We have to think about find all intervals for which g is less than or equal to 0. So I know at 2, g is 0. From 2 to 6, from 2 to, wait, hold on. You guys have already figured out the relationships, right? We know that g is equal to the integral. That means that g prime is equal to f of x, because f of u times u prime, which is just 1. We know that g double prime is equal to f prime of x. What we're looking at for where g is less than or equal to 0 or above, I'm going to think about increasing, decreasing, and I'm going to think about integration as far as the displacement, as far as the movement or the change. Katrina.
So just a question. So
Yeah.
put right there G. And that's actually a point that one of the problems.
Yeah.
If you don't mention it, but you write like under the graph G prime, do you get that or no?
Careful. If you're writing here but not in the box, there's no guarantee they'll grade it. Which is why I think it's somewhere it says make sure all your answers are contained within. So if you do write something in the graph, just make sure you state it before you keep going through the answer. Well, you have to use it.
Prime equals f of x.
Well, because, hold on, not in D, but hold on, earlier, right? With relative max min, don't you have to talk about the first derivative? And so when you talk about the first derivative, you have to somehow reference f, or else how are you connecting the information? Does that make sense? So it's not so much that you have to actually like state that, but you can state that and then use it, or you can actually just kind of naturally, organically just work it in and be like, well, as I'm explaining the derivative, oh yeah, that's f, or something like that. Yes. Let me finish the explanation real quick. So if g is seen by the values of g are seen by the integrals, then can't I say, well, if it starts at 2, as you go from 2 to 6 of f, doesn't that mean that you're adding all the... So then it's moving to the right this amount. It's moving to the left this amount. So at 10, isn't it back to 0? Because those two cancel each other out. And then what's happening after 10? Ha-ha! Negative position. Now go backwards. 0. Wait. Going backwards. If you're going backwards, you have to think of the signs as being flipped. So going backwards, then it's going to also be negative between -2 and 2. And then it's going to turn positive. Wait, is it going to overrun though?
No.
No, so it's going to go negative this amount, and then it's going to move to the right, but it's still going to be to the left, so therefore it's going to be negative. The g value is going to be negative for this whole interval as well. And you can use integrals to show that, and your areas to show that. Letter D, where g is less than 0, less than or equal to 0, or equal to, sorry, include 2. So 0 moves to the right an amount, well, it's not negative. Moves to the right an amount, moves to the left the same amount, back at 0 again. Now it's moving to the left. Oh, now its position is negative.
Why between 6 and 10 is it negative?
Because it has positive displacement. So it's moved to the right. So here's my 0. Okay? In this model, starting at 2 seconds, I move here. I stop moving to the right at 6. I come back. My position has never gone negative. My g isn't negative. I've moved to the left, but my position is still.
So you should be considering the area between below, or below it, yeah?
Where the area below cancels out the area above, where the movement left cancels the movement right, and now I am to the left of my initial object starting after 10.
So should you not be doing this in the way where x is below the x-axis and it's above?
Well, below, remember that g prime is equal to f?
Yeah.
Below, the position is decreasing, but if it's decreasing from an initial point, like it'll be decreasing for a while before it hits 0, and then it goes negative. So then, as you guys look at the pictures, they didn't even really ask for explanation, which was nice. You didn't even have to show the areas. It was more of an understanding. And P.S., if you didn't like my whole trick of starting at 2, a left endpoint, which you could find from, well, actually, no, you couldn't start there because you don't know what the initial condition would have been. No, you could, because you could have made g of -4, the integral from 2 to -4. I would start at the far left. That way you don't have to think about switching any of the signs. That might be a little easier way of thinking about it. Katrina?
Can you explain, like, C? Just like,
No, it's okay. Help me out with what the question was.
it was, justify or find the absolute max and min on the interval -4 to 4.
Okay, so good. Think about forever card, right? I need critical numbers and endpoints. Endpoints I need to consider at -4 and at 12. And then critical numbers, as I'm looking, remember that, I mean, there's a lot of times you guys have had to use this. G prime is equal to F. My critical numbers equal 0 or DNE. Bless you, bless you, bless you. Pause. Pause. I've seen APs do this. Eyes up here real quick. I've seen APs do this. What if there was a vertical asymptote somewhere? That's a DNE. You'd have to include that as a critical number and consider the signs before and after that vertical asymptote, right? Just be careful. Just be careful. But coming back, this has no DNEs. I can see, remember, F values, Y values. I can see all the Y values. There's nothing. I'm good. So therefore, I just look for the zeros. So I need to consider -2, 2, 6, 10. If you want to be lazy, and then 12 and then -4, you're like, holy cow, I'm considering how many points? If you're looking for absolute min and absolute max, oh, you're looking for both. I was going to say if it was just absolute min, you can ignore all the relative maxes. There's no way that's a min. But they're asking for both, so never mind. So we're going to test at the critical numbers and the endpoints. Now, you could actually, to be honest, you could talk about the movement in terms of the integrals and say like, oh, hey, since this integral is greater than that integral in the sense of this area covered is greater than that, or from here to here, you're moving to the right this amount. So the position, obviously, you'll be more to the right here, and then you move to the left the rest. Like you could actually explain with the areas why 6 is the absolute max. It has the most movement right. The dilemma is, where did it all start from? That would be a bit of a struggle there. Where did it all start from? Meaning my starting point is 2. So you move to the right from 0, this amount. The left 0, that. I think the easiest way that I would do it, to be totally honest, even though some people can get by writing a paragraph explanation of the movement, I would just plug all the numbers into a table. I would solve for all my areas, and I would say, hey, who's the highest? Yay, 6. Who's the lowest? Yay, 2, -2. Done. I think that's the simplest.
The way I explained it was, I said it went from below the x-axis to
That's a relative, not an absolute. Does that make sense? So you made him a candidate for the absolute min. The struggle is that's not enough to make him an absolute min. That's just a local or relative min. Yeah. Just think extreme value theorem. There has to be an absolute max, absolute min, as long as the function is continuous in a closed interval. Doesn't mean it can't be if it's an open interval. Just be careful and still try to test the endpoints or think about a sign chart with the movement, etc. But the only way to find or to justify absolute extrema is by considering the amounts at the endpoints and the critical numbers. Does that make sense?
Yeah, and then for 4, for x equals 4.
Oh, sorry.
Or negative 4, sorry.
Yeah.
Where did you get, is that the area from?
Because you think negative 4, 2 to negative 4. I mean, the bounds are awkward. I would go negative 4 to 2 and make it opposite. But yeah, you just add them all up. And then remember, since your bounds are switched, make the opposite sign. Yeah. Someone had a question on number 4, yeah? 4D?
Yeah.
I like these ones.
Yeah, it was fun.
Like the second derivative, implicit differentiation, just be careful. I don't know. I like those ones. I don't know about you guys. The relative max, relative min, use the second derivative test because you have the second derivative. That's kind of nice. Just plug in. Is it positive or negative? Second derivative. Is the second derivative positive or negative? Don't use it. Ah! Right, Gabby? She was helping me grade and had to mark off for an it, I think. Yeah, Corey.
Number B, if you showed a sign chart, that would be enough, right?
For justification?
Oh,
No.
no, for justification.
Whew! I was like,
Like if you said like by the sign chart.
Don't say by the sign chart.
No?
They never will take a sign chart for justification. You can do the sign change. Oh, wait. You can't do a sign change. You have no clue the points before or after that are actually on the original curve that you can test. The only point that you know that's on the original curve is negative 2, 8. So you have to be able to plug in at and not before and after. Because you could make up a point, but you have no clue if that works in the original function. Does that make sense? So they forced your hand. You had to use the second derivative test because only the second derivative test lets you plug in one point, consider that one point, and be able to make a justification as long as it's a critical number and you have the sign of the second derivative. Put those two together, then you can say a relative max. I apologize. You guys were asking about D, right?
Yes, I was.
Let y equal h be the particular solution. Now, they don't actually tell me to find the particular solution, right? I don't see them telling me to find the particular solution, which is, thank goodness, impossible for me to do. So if you tried that subtraction, if you multiply by dx, it's trapped. How do you get rid of that guy out of a trapped multiplication? That would have dx and that would have dx. I could do this one. This one would be impossible to get that y away. Anytime you have plus or minus with x's and y's, that differential equation, always impossible to solve. Yeah. So they're saying let. They're not saying find. So let h of x be the particular solution to the given differential equation. They tell me a beginning point using Euler's method, starting at 0, which, good, I have the point at 0. It's 2 steps of equal size to get to 1. Aren't I going by 0.5s to get from 0 to 1? So I need to go ahead and start at, sorry, here so you can see the answer key. Starting at 0, I would have written h of 0 equals 2. You guys know me. Then I would have gone to h of 1/2. Check it. This is where they would have taken the point off. They would have taken away your check mark if you didn't put approximate, if you're writing h of 1/2. You didn't necessarily need to write all the formulas, but you do need to plug in. So take the 2 and then add. Remember, plug into the differential equation times your step size of 1/2. Yes, you could have boxed it, but you had to use it again. So I don't know. I mean, if you can simplify, do it. It's easier to plug in, or just take that whole mess and plug in. Then go one more. Approximate. Plug in the earlier value of 3/2, and then the differential equation times the step size done. Gabby. Yeah.
How did they find the value of
Okay, so G prime. Hold on, who is G? G is the particular solution to the differential equation. Okay, G.
It's dy dx is the derivative of g of x. Yeah. Because G of x.
to the given differential equation.
So the given.
So this is the derivative of that.
But how would you?
Does that make sense? How else would you? You know what I mean? Because as you go here, do you have a g? No. How would you get to g? Integrate. The minus, you can't integrate. It never says, now just think about it. If they were asking you this question, do you think they really, if the point of this question is the limit, do you think they would really put in like 5, 6, 7, 8 points of differential equation work if they're just asking for a limit? No. You know them. They make that the highlight. They make that the star. They make that a whole problem in and of itself. So if they wanted you to find the particular solution, solve for y equals g of x, the particular solution. Evaluate? It's usually find. They wouldn't just put in this soft little like, oh, let this be true and now use it. So think L'Hopital's whenever it's not an obvious. If you try to plug in -1, who's g of -1? I don't have him. Don't go spending tons of time finding him. There must be another L'Hopital's way. Yeah. Actually, hold on. They gave you. Exactly. 0 over 0. 0 over 0. How else would you do it? Sorry, that's a better way of explaining it. 0 over 0 L'Hopital's. Caroline. Yeah. Yes. Oh, it's okay. Remember, h is the actual, so then the actual is approximated by Euler's. So h is approximately. That should be okay. Because your y sub 1 is your approximate y values from Euler's. That's okay. But they called y equals h of x, didn't they? La, 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 la. I think you would still be okay because I think this would be safest. I'll put it that way. But in my experience, in my imagination, I don't know my deduction would be that almost all teachers know that y1, y2, y3 is how kids have learned Euler's. So then we would associate that with the y steps of Euler's and not with that y. So I think you would be okay. But I mean, better safe than sorry. Maybe a point would make a difference, so you might want to go ahead and change up your notation. Okay, did I miss any questions? We've done 3, we've done 4, we've done, I don't even know. Any D's that we missed or any FRQs that we missed?
60.
Oh, 6D. I thought I said 60.
Oh, wait, 6 delta.
We did this one yesterday? Oh, yeah, we did the whole thing. We did the whole thing. You were thinking that, yeah. Aw, you're trying to be mischievous. Okay, 2016. How many of you guys didn't find the answer key online last night, so you weren't able to finish grading in class today? Okay. Let's go ahead and, but we didn't look at all the FRQs, so I feel bad. If you're ready to pass them in, go ahead and pass them in. I'm going to go ahead and have it be in the tray. Tomorrow, 2016, yeah. So if it's not graded, hold on to it, grade it tonight, put it in the tray tomorrow. I'll grade it tomorrow. Sound good? But some of you might lose it in between now and then, so let's get it back there right now. Yeah.
I looked at the answers, I finished and everything, then I switched the answers. I graded it, but I didn't read the marks and stuff.
Put a quick little. Well, you have that one. I would presume. John, here you go. That's okay. That's okay. For you guys, I understand that you can count them up and. All right. So you guys have the BC review number 1 in front of you. There are some multiple choice and there are the FRQs. This one is due tomorrow for us to go over questions. The answer key. Ooh, the answer key. Go team. Hey, look. Guess what I did? Now, guys, pause. I have the actual AP FRQs because they are actual AP FRQs. That's why I like these reviews even a little bit better than the laying the foundation ones. Plus, these ones are mixed up, so it keeps you on your toes. You have to keep on recalling from different places, which is nice. AB, as you guys know, we're doing kind of topic by topic, which includes review, but just trying to get them to get the foundation down. But for you guys, the mix is a good thing, right? But pause. Keep an eye open on my FRQ. Don't take it as gospel truth, because I think I kind of just did it without actually referring to much. So if you do find a mistake, let me know the next day. Sound good? Don't make a big deal of emailing me and all that jazz. Just go ahead and check it out, see if you agree. And if you disagree, that's all right. Gives you another reason to dig a little deeper. Bye, guys. Due tomorrow. BC review number 1. Yuki. Sorry. That's okay. Give it to me Monday. You're good. That's true. So physics people and... Oh, so we're going to miss... Okay. Tomorrow might be a work day then.